morning, students. Welcome back to the Science 1 class. Today, we are going to learn about atmospheric pressure and Pascal's law. Under 9, you have already learned about atmosphere. What is atmosphere? Envelope of air is known as the atmosphere. The atmospheric air extends up to 300 km above the Earth's surface and clings to the Earth due to gravity. The atmospheric air exerts force on all the objects in the atmosphere and on the Earth. The force or thrust exerted by the atmospheric air on a unit area is defined as atmospheric pressure. The approximate value of atmospheric on the Earth's surface is 1.013 into 10 power 5 Pascal. The atmospheric pressure at a point is the same in all directions. Sin above the Earth's surface in different layers is called the atmosphere. The pressure exerted by the atmospheric is called atmospheric pressure. Air exerts pressure as has weight and pressure. It is the highest at the sea level. The air pressure decreases at higher altitude because the height of the air column decreases, which causes a linear decrease in air pressure, and pressure decrease at higher altitude. Also, the density of air decreases. Air pressure decreases by about 3% for every 1,000 feet of increase in height. For example, Mount Everest atmospheric pressure is only 30% of the atmospheric pressure at sea level. To stay alive, the mountaineers are left with no other options than to carry the oxygen tanks with them. And air pressure decreases in hilly areas, we can feel our ears pop, which happens in order to balance the pressure inside and outside of body. To decrease in air pressure may cause the nose to bleed, especially in the individual has high blood pressure. This is because the air pressure cannot completely counterbalance the blood pressure, causing the blood vessels in the nose to rupture. That's why doctors advise blood pressure patients to avoid going to hill station. Thus, atmospheric pressure decrease with altitude due to decrease with height of the air column, which causes a linear decrease atmospheric pressure decrease in the density of air, which leads to decrease in atmospheric pressure. Next, we'll see gauge pressure and absolute pressure. Our daily activities are happening in the atmospheric pressure. We are used to it and that we do not even realize when tire pressure and blood pressures are measured using instruments. Gauges we show the pressure over the atmospheric pressure. Hence, absolute pressure is zero reference against the perfect vacuum, and gauge pressure is zero reference against atmospheric pressure. Let's learn detailedly about gauge pressure and absolute pressure and how to measure these two pressure. How they are measuring gauge pressure and absolute pressure. In this figure, we can able to understand that what is gauge pressure and absolute pressure. The center blue line is atmospheric pressure. Above the atmospheric pressure will denote as A. Below the atmospheric pressure will denote it as B. if I take any pressure from absolute zero, that is known as absolute pressure. Okay, if you measure from absolute zero, maybe above the atmospheric also, it is known as absolute pressure. If I take any pressure above the atmospheric pressure, is known as cage pressure. Above the atmospheric pressure is positive, below the atmospheric pressure is the negative. Next, the pressure below the atmospheric pressure is known as vacuum pressure. So, absolute pressure is measured from absolute zero. Cage pressure is measured above atmospheric pressure. I think now you understand. Now pressures higher on atmospheric pressures. Absolute pressures is equal to atmospheric pressure plus cage pressure. For pressures lower than atmospheric pressure, absolute pressure is equal to atmospheric pressure minus cage pressure. We have seen that liquid column exert pressure. So the pressure inside the sea will be more. This is more than twice the atmospheric pressure. So a part of a body, especially blood vessel and soft tissues, cannot withstand such high pressure. So that scuba divers always wear special suits and equipments to protect them. Next, we'll move on to barometer. Barometer is used to measure the atmospheric pressure. Let us study the construction of a barometer. First, take a capillary tube of 100 centimeter. Its one end is closed and other end is open. A funnel is fitted in the open mouth and very dry pure mercury is filled in it. After filling mercury in the capillary tube, it's put on inverted position in the trough containing mercury. The open end of the tube is closed with the thumb and end dipped in the mercury trough. Students, the thumb is removed very carefully so that no air passes in the capillary tube. The tube is supported with the help of stand and graduated scale input parallel to it. After some time, the level of mercury begins to fall and become stationary. The height of mercury column is measured from the surface of mercury in the trough. This height is 760 millimeter or 76 centimeter. Therefore, it's also called 760 millimeter mercury. That is 760 millimeter height of mercury column at sea level. As mercury falls, it leaves empty space above it. This space is called Doricellian vacuum, since it was identified by Doricelli. As the altitude increases, the pressure decreases. As the air pressure decreases, the mercury column in the capillary tube begins to fall. Thus, mercury barometer is also used to finding the altitude or height of mountain. Let's calculate the atmospheric pressure at sea level in Pascal. The atmospheric pressure is equal to pressure exerted by the height of mercury column H in multiplied with density of mercury and acceleration due to gravity. 0.76 into 13,600 into 9.8. We get 1,0293 Pascal. Next, we will see Pascal's law. Let's understand Pascal law with two examples. We take a rubber ball filled with water and now we pierce holes in it with pen in different places. If we press it hard, water will rush out of all the holes with equal force. You know, the scientist Pascal said if we apply pressure at any point of confined fluid, it will be transmitted without any change to every other point in the liquid, which means the pressure will be transmitted equally in all direction. So the pressure we applied is transmitted equally in all the directions. Thus water is coming out of all the holes with the same pressure. This is known as Pascal's law. Another example, Pascal's law can be demonstrated with the help of a glass vessel having holes all over its surface. Fill it with water, push the piston, the water rushes out of the holes in the vessel with the same pressure. The force applied on the piston exerts pressure on water. This pressure is transmitted equally throughout the liquid in all directions. Next, we will see hydraulic press. Hydraulic machines are used tool that are use liquid fluid pressure to do simple work. According to Pascal's law, the pressure applied to an enclosed incompressible fluid is transmitted unchanged over every part of the fluid. Here, there is a model of simple hydraulics that uses the principle. It is a U-shaped tube which has two arms and they are closed by two leak proof pistons. The two arms are different cross section. One arm has larger cross section than the other. So here we say A2 is greater than A1. When A1 and A2 are the cross section of the two arms of the U-shaped tube. Now when we apply the force which is equal to F1 left piston, then it will create pressure which is equal to F1 by A1. As we know, pressure is equal to force by area. Now the cross section A1 is small, so we can generate greater amount of pressure and force F2 acts on A, which is much larger than F1. Pressure on piston of small area is given by P is equal to F1 by A1. Applying Pascal's law, the pressure on large piston of area A will be the same as that the small piston. Therefore, P is equal to F2 A2. Comparing equations 1 and 2, we get F2 is equal to F1 into A2 divided by A1. Since the ratio A2 divided by A1 is greater than 1, force F2 that acts on the larger piston is greater than the force F1 acting on the smaller piston. Hydraulic system working in this way. Thank you, students. That's all for today's class. Have a good day.